But organizing DevOps has these little magic things, you know. We have our rock stars, and we thought, we would love to invite people to come and talk at DevOps France. We thought of Steve Jobs, rest in peace. We thought of the other, other guys, and we did a wish list, and on top of the wish list was Neal Ford, who is one of my, I'm a fan of Neal. I've seen him talk many times. So that's a good thing of, organizing DevOps is you can pick up your rock stars. Some say no, and some say yes, so thank you, Neal.
Thank you.
So Neal was here on Wednesday. He did a lab, so, in small rooms, there was about 40 or 50 people who had the chance to spend 3 hours with Neal. So he arrived on Wednesday, but what you don't know is he flew to Germany in Frankfurt, and then his plane was cancelled to Paris. So he had to drive with his wife from Frankfurt to Paris. He arrived at 3 a.m. in Paris at the hotel, did his talk, visited Paris yesterday, I hope, and today he's here for the keynote. Thanks, Neal. Really appreciate it.
You're welcome. Thank you very much. So the talks that have been already this morning are about where you want to live. I'm going to talk about where you live now. This is my talk called Abstraction Distractions. And here's the idea behind the talk. As developers, we spend our entire lives on top of abstraction layers. We have to, because otherwise we'd never get anything done. You can't think of a hard drive as a platter with rust on it that spins, that has a head that moves, because you'd never get anything done if you had to think at that level. So we build file systems and folders, and we build all these abstractions on top of these really complicated pieces underneath, which is good. This is the reason that we can build mobile applications now and web applications, because if you had to deal at the ones and zeros level all the time, you'd never get anything done. But along with that comes a really serious problem, in that we spend so much time in these abstractions that we start forgetting that they are abstractions and start thinking they are the real thing. And that's when you get in trouble, because they're not the real thing, they are just an abstraction over a real thing. And that's what I'm calling an abstraction distraction. And I'm going to show you lots of examples of these, both in the real world and in the computer world that you live in now. Before I do that, though, I want to motivate a real problem that I have at home. I'm guessing, like many of you, I am the IT support staff at my house. And it doesn't matter if a meteor comes from space and hits my house. If we lose our digital photos, it is my fault. And so I've gotten very paranoid about keeping track of my personal IT data, in particular really valuable pieces of data, like, for example, this. This is a recipe that my wife got from someone at great expense and effort. And she let me know in no uncertain terms that I cannot let anything happen to this chocolate cake recipe. So now the question comes up, how can I keep this chocolate cake recipe on a computer for 100 years? Would you put it in Word? I don't know. Maybe in 100 years you could read a Word doc, but I don't know. I don't know if I want to trust something as critical as the chocolate cake recipe to Word. I trust it for some things, but not everything. So I think you're probably still better off just with plain text. You might, but now the question becomes, do I go Unicode or do I say ASCII? Unicode's probably pretty safe, but you know what? I bet you'd be able to read ASCII in 100 years with no problem. I might even get really fancy and go HTML, which is still text-based, which means I could still see the stuff if I really had to, but maybe there'll be a browser, maybe IE6 will still be running in 100 years, and I can view it in that. This is a casual concern for me, but for a lot of people, this is deadly serious, and it is a really hard job. Because this is the group in Washington, D.C. who has been tasked by the U.S. government to keep everything. What format are they going to keep that in? They're in a blind panic. They have no idea, and there's so much data being generated now in so many different formats, how can you possibly keep track of all this stuff? There's another group of people who's also thinking about this problem in a slightly different way. There's a project called the Clock of the Long Now project, where they want to build a clock that will last 10,000 years. So how can you build a clock that will last 10,000 years? Well, it has to be run by some sort of natural occurring energy. You can't expect electricity is going to last 10,000 years. And so this is actually a prototype. This is 12 stories tall. It's driven by a river. They've located a place in the American Midwest that's very geographically sound because you don't want an earthquake messing it up in 10,000 years. And they've got this prototype, and they've actually bought a piece of land. So imagine, if you will, in a few years, a big giant 12-story clock right there. That's what the Clock of the Long Now project is thinking about. And they're thinking about these long-term solutions to problems. But how to keep this really important document is really an abstraction distraction. I want to keep the information, but to keep the information, I have to push it down into some sort of physical format, and physical formats all have limitations of various kinds or another. I'd love to just keep that information pure, but it's really hard to do that because all of our abstraction layers fight you all along the way. So my first lesson is don't mistake the abstraction for the real thing, which is really hard to do. And you think this is minor, but if there is a piece of software that will last 10,000 years, it is Emacs. And I'm doing everything I can to make that happen. But what's tragic and sad about this is the very first check-ins to Emacs, the very first check-ins to the repository for the original version of Emacs, they still have the tapes, but they don't have a computer that can read them. So in 10,000 years, historians are going to look upon us as irresponsible because we destroyed the first few check-ins of what became Skynet. And that's really irresponsible, because I'm sure Emacs will eventually become Skynet if it keeps going. So next, I'm going to tell you a bit of a story of my very early career, actually before I really got into computer science. And there are two things I need to tell you about this story. One is that the outcome of this story should have been that I spent time in jail, but I didn't, which is good. The other thing is I'm going to give you a lot of really detailed business rules about a particular problem domain, and it's going to seem like that annoying guy that you meet in the hall that wants to give you really way too many details about the thing he's working on, but trust me, it's worth the trip. When I was working my way through university in the U.S., I did so as a night auditor at a hotel. And it turns out this is a really terrific job if you're in university and have to work your way through school, because a night auditor is the person who mans the front desk all night and does the daily accounting for the hotel. And so the night auditor has very specific responsibilities. You have to take care of the daily accounting, the late check-ins, and help with any guest problems that come up. You also have to not get drunk and not sleep. And those two things were really emphasized during the hiring process, that we're really concerned about these because obviously you're no good if you're drunk or asleep. And this is why it's such a great job if you're in university, because once you get good at the accounting part, you can get that done in 3 or 4 hours and now have 4 hours at work where you can also study. And the manager loves that because the manager knows that you're not sleeping or drinking, you're studying, which means you're awake and alert, so you can handle anything that comes up. It's very nice. Now, when I first started in the hotel business, it was using a cash register that looked like this. This is actually the best screenshot I could get of a really old cash register. And these things worked in a very interesting way. They had no intelligence whatsoever. They were stateless in our modern terminology. They could add numbers together. If you gave them numbers, they would be calculated, but they didn't remember anything between transactions. So the way that you worked with this is you had a paper folio. And you'd stick the paper folio in the machine, and then you would start ringing up charges. You had to pick up the previous balance first, and then you'd ring a room charge and a tax, and then it would calculate the last balance. It was a good adding machine. But then, So it worked fine. So what happened was when you do an audit on this machine, what you do is sum up everything that's been added on all the keys, and you take every previous balance from yesterday and add the new balances from today, and those two things should match because that's how much you've added for the day. That means your audit's in balance. But this thing is very stupid, so when it comes time to add a new charge, you have to put the piece of paper in, and then you have to type in the previous balance, because it doesn't know what it was, but then you add a new charge and it will add it for you. This hotel, by the way, has the exact same feature. I got a voicemail in my room, and there's a message that says, type in your room number, and it gave me the room number right there for me to type in. It's like, why didn't you just type it in? You knew what it was. So that's the basic idea. This is the whole idea of an audit, is to add up the things that have changed to make sure they balance. And there are really only a couple of things that can happen to go wrong in the system. One of them is this. Transposition errors are very easy when humans are picking up previous balances, and so you learn an auditor's trick that if the amount that you're off by is divisible by 9, then it's probably a transposition error, because all transposition errors are divisible by 9. That's kind of nice. The other thing is there was nothing to force you to be nice and neat and orderly on the piece of paper. So you'd have some desk clerks that would cram the piece of paper in there and end up stamping stuff all over it. And now the night auditor has to go and untangle all this and figure out what they really did. And this caused a lot of nasty looks the next morning when you saw that person to relieve them. But that's basically how it worked. So I moved from that hotel and actually moved to Atlanta, Georgia, where I live now, to go to university. And went to work at a much nicer hotel. It's called the Regency Suites Hotel in Atlanta. And in fact, that's a picture of that building. And I was a computer science major at Georgia Tech. And when I got to the Regency Suites Hotel, this new hotel, they had a significantly upgraded hotel system. It was computer-based. In fact, it ran, this is in the late 80s, it ran on an IBM AT computer, which is a 286 computer with a 20 megabyte hard drive. And what was really remarkable about that was the people who had built the software had figured out a way on this computer hardware to be able to hang terminals off of it so that you could run the entire hotel with this one 286 computer. I was impressed. I'm a young computer science student. I saw this. What was even more impressive, they wrote the whole thing in BASIC with line numbers. Because you'd see it crash every once in a while, and you'd see line number BASIC. It's like, wow, these guys built a distributed system on a 286 computer using BASIC. Wow, that's pretty impressive. But the audit at the computerized hotel is completely different, because at the computerized hotel, you just punch some buttons, and it spits out big, giant piles of paper. And you file all the paper away, and you do backups and other things. There's still things you have to do, but the accounting part of it is supposedly taken care of by the computer-based system. Except that every once in a while, it would get out of balance. And that was driving me crazy. I'm a computer science major. Computers are supposed to be deterministic. They're supposed to always do the same thing, and it didn't seem logical that it would get out of balance every once in a while. And then one night, I figured out why. It's because in this multi-user system they had created, they didn't bother implementing any locking, as in no locking, as in no locking whatsoever. So my respect for these guys went from the highest mountain to the deepest valley, because they're now selling the worst software ever. Because the busier you are, the more likely you're going to get these bad problems, because now you have concurrency hell and there's no locking whatsoever for user records, which is awful. And I went to the manager and explained this because I was very concerned. And she was like, so? She didn't get it. She didn't see it as a problem. This is some kind of computer detail that this computer geek is telling me about. I don't care about that. So one night, late at night, I was working on the night audit, and someone came to check in who was paying cash. So I took his cash, gave him a hotel key, and sent him up to his room. I then started the night audit on one computer. While it was running, I went to another terminal, checked him in, checked him right back out while the audit is still running, took the money and stuck it in an envelope, put a date on it, put it in the safe, and then went home. The next day, when the accountant for the hotel arrived, something was weird, but they couldn't figure out what it was. And so they were looking at it and trying to figure it out, puzzling it over for a few days. They brought in a consultant from the idiot consulting company that wrote the software who looked at the problem, and then he looked at the problem, and he looked at the problem, and then he eventually disappeared. I'm not sure exactly what happened to him, but he was not around anymore. Meanwhile, I was just kind of hanging out because I knew exactly what had happened. I had the money in my pocket in an envelope or in the safe. And so after about a week of them stewing over what could have possibly happened here, I told them exactly what happened and gave them the envelope of money and said, now do you see how this might be a problem, that you can't lock the system? That somebody could come in here and rob you blind overnight, one of your employees, without you realizing it? That caught their attention. Overnight, one of your employees, without you realizing it? That caught their attention. But realize that this is really just another version of an abstraction distraction, because everybody that worked in that hotel had come from the paper folio world. And so they thought of paper folios as being these immutable things, these stateless, immutable things. When they moved it over into a computer system, the immutability went away, because now it's mutable, and in fact multiple users can get at it. And they didn't understand that distinction, which was really dangerous, because they were setting themselves up for some clever person who's not quite so honest to really, really rob them blind. Which is back to my lesson number 1, don't mistake the abstraction for the real thing. But it also leads me to lesson number 2, always understand one level below your normal abstraction level. Because when your normal abstraction level breaks, and it will, it's not a question of if, it will always break because it's an abstraction, it's not the real thing. You need to understand one level down so you can figure out why it's broken and fix it. I realized this over Christmas this last year, because I realized I watch TV in a particular way. Now, like most everyone in the world now, I have a digital video recorder. But I've noticed that when I sit and watch TV, I will wait until a commercial comes on and then pause it and get up and go to the restroom. Because I've been trained my entire life, you don't go to the restroom except during commercials. And so even though I can stop and start it at any time, it's natural for me to wait for that commercial boundary to stop it and get up and do what I'm going to do. My mother, who's a generation older than me, doesn't believe that it exists unless you see it live. So she has a VCR and a DVR, but she never uses them. In fact, we'll be there at a family gathering, and she'll say, oh, I have to go upstairs and watch my TV show. It's like, Mom, we only get to see you 3 times a year, and you're going to watch a TV show? It's like, yeah, but it's only on now. It's like, no, it's not. It's on always. Not for her. For my 9-year-old nephew, there is no such thing as time that TV programs are on or not. They all have a release date, and then you can just watch them anytime that you want. My friend Matthew has a very young daughter, and they watch a lot of cartoons on the iPad, and he turned on the TV one morning, and the show had already started, and his daughter said, Daddy, why did you start it without me? He had to explain to her, I didn't start this one. It actually, somebody else starts that one. Which just shows you that once internalized, abstractions are really, really hard to shake off. Incredibly so. And if you don't believe that's true, just look down. This is not the most efficient way to lay out a keyboard. In fact, it is specifically designed for a particular kind of inefficiency. Because when they originally designed typewriters, they looked like this, which had big arms that would fling up and hit the ink onto the paper. And really fast typists, if they got hands too close together, the 2 arms would jam, and then you have to correct that error. So they laid out the QWERTY keyboard to optimize this motion. Left and right, left, right, to keep the arms from banging into each other. The Dvorak keyboard layout is much more efficient, but you want to talk about true pain and suffering? Try relearning to type. That's how deep these abstractions go. And in fact, it brings me to lesson number 4. Abstractions are both walls and prisons. They start off as being walls. They protect you from the messy outside world, and it's nice because now we're safe inside our wall. But the walls grow over time, and they close in, and before long you realize, wait a minute, these are not walls, this is actually a prison cell. Here's another good example of an abstraction distraction. This conference used to be called this. Actually, the Belgian version used to be called Javapolis. And they were forced to stop doing that, even though it was known as the Java 1 in Europe by some, because they didn't want people using their precious Java word. Even if it's a really positive association, they forced them to change their name. And of course, Devox in Belgium became now Devox France, which is where we are now. But this, of course, is just a lawyer-based abstraction distraction. They're making it less accurate just to satisfy some sort of legal nonsense. You see a lot of this in the patent world in the US right now, the stupidity around patents. You don't really apply patents to things like one-click shopping, and people are trying to do that. Another one of these terminology things actually came up in the opening keynote this morning, and it's not his fault. A really common term now in the mobile space is transcoding. I call bullshit on transcoding. It's code generation. That's what it's always been. And we know that code generation has pros and cons. By calling it transcoding, you're hiding the things that we already know about this really important, valuable technique. Stop building new words for things we already have perfectly good words for, unless you guys want to build a French version of the word code generation. I'm perfectly okay with that. I saw this in London a couple of weeks ago. This is a sink designed by someone who has apparently never washed their hands in a sink before. It's either ice cold or blazing hot, and there's no alternatives. Once internalized, abstractions are hard to chase off. Hey, there are two pipes there. That means I have to have two spigots on it. I realized how deep these abstractions go when I first saw Gmail. Now, I was a big user of Outlook and started using Gmail. When I first saw Gmail, it's like, wow, these Google guys don't know what they're doing. They didn't even create folders in Gmail. How can you have mail without folders? That's just silly. And so I did what a lot of people did. The very first thing I did was replicate my gigantic, stupid folder structure as tags in Gmail, because I guess that's what you're supposed to do here. And then one day I realized, wait a minute, I can actually put more than one tag on something. This is way better than a hierarchy, which forces you to put it in one place because there's no reason to put it in just one place. Only the limitations of the filing system forces you to put it in one place. Which got me thinking about other hierarchical things that are broken with abstraction distractions. Like this. The way that we identify plants and animals on this planet is hierarchical, and it should be tag-based. Because if it were tag-based, we could finally accurately label this thing. A platypus is a mammal that lays eggs, and for some reason, only their left ovaries work. It's true in every platypus, only their left ovaries work. It turns out that trying to force everything into hierarchies doesn't even work in physics. There are some materials, this is actually corn syrup, but if you vibrate it at a certain frequency, it takes on the properties of a solid. So this is actually between the state of liquid and solid at the same time, and our hierarchy can't handle this. The physics hierarchy doesn't know what to do with this substance that is always in this transitional state when it's under vibration. Abstractions are both walls and prisons. Now, I'm sure most of you spend a lot of your day looking at this. This is the ribbon bar in Word for Windows. I have a question for you, something I've been wondering about for a long time. What the hell is that thing? When was the last computer you had a floppy disk in it? And more to the point, okay, so if I buy this metaphor, then what the hell does this mean? This means it's so big I need more than one floppy disk to put it on? More than one floppy disk to put it on? This is a total abstraction distraction. Don't name things that expose underlying details, because you're just going to suffer from it later on. In 10,000 years, people are going to say, what does that icon mean? That's the abstract icon for save. They're never going to know that was a floppy disk. What's a floppy disk? What's a disk? What's a computer? Speaking of what's a computer, there's a great advent that showed us how deeply we were imprisoned by our abstractions when this came along. Because this is a computer, but it's a weird computer. Because for the first time in about 30 years, we have a computer that has no keyboard, it has no mouse, has no file system. Of course it has a file system. We're developers. We know it has a file system. But you never show it to the user, because users don't want file systems. They want applications that work. How many of you have walked one of your relatives through this chore? They've downloaded the family photos, and now they can't figure out where the file is in their file system. Now you're chasing down a zip file somewhere on their desktop or their downloads folder or wherever it is. People don't want file systems. File systems are developer conveniences, and we've imposed this on our users because we weren't smart enough to hide it until this came along. The only time this ever exposes a file system is through something like Dropbox, a cloud-based file system so you can select files. You never, as a user, see the underlying file system, which is perfect. And in fact, notice the uptick for this computer for people who don't really think of it as a computer. 3-year-olds can pick this up and start using it. They don't have to learn to click a start button or anything like that. They can intuitively pick it up and start using it. Once internalized, abstractions are hard to shake off. I had a friend one time tell me, I see the Macs and they're nice, but I just like Windows better because it's more intuitive. This is back in Windows XP, and I said, so you believe that it's intuitive to click on the start button to shut it down? He said, you know what, you're right, I'm just used to it. A lot of you probably recognize this book. This is a classic in the Windows programming world. Charles Petzold's first programming Windows book. It was the first one to introduce us to this lovely concept: a long pointer to a null terminated string, and the idea of Hungarian notation. In fact, if you look a few years later, this is a bit of documentation about the Win32 API, and it says, and I'll excerpt this paragraph, remember a few things. It basically says an LP prefix stands for long pointer. In 132, the long pointer is obsolete, so don't worry about it, except that you have to type it in every single time you use a parameter for anything. Because the entire Windows 32 API had long pointer to null terminated string as Hungarian notation on every parameter that was a long pointer, and then when they went to 32 bits, long pointers went away. But the name couldn't go away because they've defined the API in terms of this for 1 million years. That's a total abstraction distraction. Don't name things that expose underlying details, because you always suffer from that later. Now, one of the things that you've probably read about abstractions is this really powerful idea of leaky abstractions. In fact, Joel Spolsky very famously talked about leaky abstractions in this blog entry from back in 2006, I believe it was. There's a date on there somewhere. And he talked about the law of leaky abstractions. He says that all non-trivial abstractions, to some degree, are leaky, meaning that they don't perfectly abstract the thing that you're after. They leak some details. And when he talked about this, it was as a bad thing, that this is a mistake on the application developer standpoint because they couldn't get the abstraction perfect. But it turns out that they're not all bad. I have a friend, Glenn Vanderburg, who's a really well-known thinker in the software world, and he's got a great take on this. He says that some leak in better ways than others, and the very best abstractions leak intentionally in carefully chosen ways. And he's got a special name for these. He calls these onion skin APIs, which is a high-level abstraction built on top of an equally well-documented lower-level abstraction. A classic example of this is Active Record in Ruby on Rails, which has 5 distinctive abstraction layers built into it. The bottom layer is vendor-agnostic database connections and facilities. Then you have query to object instances, SQL fragments composed into select statements. This layer, high-value relational algebra methods, was actually inserted in the last version. And then you have these query instances that are modeled on classes. When you look at Rails tutorials, they really only go down to about the first level, but in pretty much every non-trivial Rails application, you always go down to at least level 3 in some cases, because the abstraction is there. In some cases, you will go all the way down to the 5th level if you need to for reporting, things like that. And so my lesson number 6 is actually a good thing. Good APIs are not merely high level or low level, they're both at the same time. That gives the user the ability to work against the very highly abstract version, but then get to the lower level details if they need to. And this is exactly the design philosophy in Rails. 80% is really easy to cleanly abstract. The other 20% is monstrously difficult. And the Hibernate guys are tackling that last 20%, which is really, really hard. It's way harder than the first 80%. The Rails guys said, you know what, we're not going to bother with that. We're going to make our abstraction leak in very well-defined ways and let you take over when this situation comes up. We're not going to try to code our way out of this. We'll just let you do it because you know what you're doing. Which is lesson number 7, generalize the 80% cases and get out of the way for the rest of them, because that last 20% is the most effort, and in fact the last 1% is probably more effort than the entire thing was leading up to it. Which leads me to Galileo, who greatly suffered from abstraction distractions, because he believed against the current thinking of the day. Predecessors to Galileo believed that this is the way the universe worked. And several people right before Galileo, like Copernicus, said, nope, that's not right. It makes a lot more sense if it's like this. Of course, this is why we know it is. But Galileo, who was really a strong proponent of this, really got in trouble with the church, who was really against this idea. And so they actually drove him out of business and made him move. He was cast out of his community and died really, really upset. Even though he really loved the church, he couldn't figure out why they were ignoring this really plain truth. So he died kind of penniless and stained with a miserable death. Which brings me to Maven. Maven is unusual because it's a tool that generates giant passion on either side. In fact, one of my colleagues is a guy named Kent Spillner, the most easygoing guy you will ever meet in your life. And Ken says in his blog, Maven builds are an infinite cycle of despair that will slowly drag you into the deepest, darkest pits of hell where Maven itself was forged. Now, why would a mild-mannered developer say something like this about a tool? Well, it turns out that Maven is a very special category of tool, and I'm going to broaden this category greatly. What I call composable versus contextual tools. Composable tools are ones like Bash, where you basically everything's just text and you compose the pieces that you want by wiring things together, versus something like PowerShell, which is based on a plugin model. It's much easier to write simple things in PowerShell because you have properties on things, but there are some things that Bash can do that PowerShell just can't, because in Bash you can really manipulate the text and get to more underlying details. Rake and Gantt are composable because they're language-based. Ant and Maven are contextual because they're plugin-based. And plugin-based systems make it really hard to get under the plugin API to do useful stuff, whereas composable systems tend not to do that. Tools like Emacs and VI are very composable, whereas Eclipse and Visual Studio are very contextual. If you're an Emacs user, you probably make some minor change to your environment every week because all the little pieces are there. But if you're an Eclipse user, you never customize Eclipse through their plugin API because it would take you a week to learn just enough to instantiate a single window, and nobody wants to spend a week customizing the tool that you're in when it's so difficult to do. This is also true of languages and frameworks. Languages are very composable and frameworks are very contextualized. Everything works great as long as you fit within the framework. When you step outside of it, you run into trouble. Which is to say that more context is not necessarily a bad thing because you get more behavior right out of the box. It's useful right away. You get more contextual intelligence, but you get less flexibility because you can't get underneath all those levels. Whereas composable systems, you get less implicit behavior, but better building blocks for more eventual power, but less initial power, but more flexibility. Which leads me to Dijkstra's law. This is an observation that I made in my book, The Productive Programmer. I used to work for a company that did, among other things, Microsoft Access development. And we eventually shut down that division because every Access project started out as a great success and ended in failure. And we were curious as to why that was. And we codified Dietzler's law from that, which is this. Using a tool like Access, or any contextualized tool, 80% of what the user wants is really quick and easy, and it's amazing how fast you can get it done. This is rapid application development at its best. But then the next 10% of what the user wants is possible, but difficult, because now you've got to get underneath or around or hack the tool, because it doesn't really want to do this, but you can kind of twist its arm and get it to bully it into doing that. But the last 10%, you cannot get there because you can't get far enough under those abstractions. And it turns out users always want 100% of what they want. They're never satisfied with 90% of what they want. This is why 4GLs died in the late 90s. They all suffered from Dietzler's law. At some point you hit a wall where it's like, I'm sorry, I can't deliver that functionality, so we all went back to general purpose programming languages because they're more composable. They're not contextualized. When you look at a tool like Maven, how do you choose? Because Maven gives you enormously cool stuff right out of the box. So what you do is you start with the easiest. And when it's the easiest, when it's brand new, you want something that's opinionated. Tell me how to lay out my files. Okay, good. That's good. You want something that's dogmatic and rigid and generic, because every project is generic at the start. But over time, your project gets less and less generic. And those things that started out as advantages start turning into disadvantages. The opinion that was so great when you started, when it starts differing from your opinion, it starts being bad. And the dogmatic idea that you have to put everything here and I will control your build cycles is great until you end up having to compile your code twice just to run unit tests because you can't convince Maven to do it in an intelligent order. This is really hard because once you start using a tool like that, you're reluctant to give it up because you've invested a lot of time in it. But every tool like that reaches a tipping point. And once it goes over that tipping point, it will never, ever be wonderful again. In fact, it'll just be painful from that point on. So I'm not suggesting that you don't use Maven. When you start a project, you should absolutely use Maven, because it's the easiest way to get things bootstrapped up and running, Sonar plugins and code coverage and all this stuff. But keep a wary eye on it, because there will come a day when you have outgrown it and you need to replace it with something more composable. And if you put it off too long, it's going to be that much harder because you've invested that much more time in hacking the thing that will never actually work to get it closer to where it will work. At some point, you've got to cut and run. But it's hard to do this because you've already invested time and effort into the thing that you're building, but you have to do it, otherwise you'll end up suffering a lot of pain. In fact, I picked Maven because it exemplifies virtually all of my bad abstraction distractions and neither of the two good ones. So, is there one true abstraction? Probably not. But if there is, I think it's probably composability. Because if you look at, in the book Effective Java, he talks about the inability to write a proper equals method in the face of objects, which the Scala guys have kind of fixed with an extra method, but he fixes that with composability. If you look at something like Git, I really love Git because it's really, really composable. It's an onion skin API. In fact, the thing that is replacing 4GLs are domain-specific languages, because notice they have the exact same characteristic of a 4GL. Look at Ruby on Rails. It looks just like a 4GL, but the difference is it's an onion skin API. The lower level abstraction is as well documented as the top level one is, which means that you work on the top level abstraction until you need to dip down, and it's easy to dip down now. So DSLs killed 4GLs, and you'll see a lot more of this done in that space. These are what I call 21st century 4GLs, and you see this pattern a lot. So to wrap things up, to answer the question that I posed originally, what did I eventually do with Mary Long's chocolate cake recipe? I have a RAID drive at home, so I put it in Unicode and Markdown, which is really nice text and can be translated to HTML probably, and I keep it on an external hard drive, a RAID drive, and then on CrashPlan, which is a cloud-based service, because as far as backups are concerned, my abstraction is suspenders, belt, and duct tape. Because I don't trust computers, because I've worked with them for a really long time. I never trust computers with precious things like Mary Long's chocolate cake recipe. So don't be distracted by your abstractions. And I have one last piece of advice for you. Please enjoy the rest of the conference. Thank you very much for coming. Thanks for having me. Thank you very much. Thank you.